So this very first part of the video is only here to remind you that we did 8.1 and 8.2 already, being area and circumference of circles and then equations of circles. We did those in class together before spring break and after spring break. I just didn't necessarily give you the unit and section number for that. So just keeping in mind that these are two things that we did in class. And the reason I say that is because here's your first video of the unit and it's actually the third section that we're going to cover. So what we're going to do today is find measures of segments that are that intersect in the interior of a circle and then also in the exterior of a circle. So first thing that we have is a chord intersection. Remember, a chord is it goes from one spot on a circle to another point on the same circle. So just anything. So both of these are considered chords because that's what it does. So what you're going to do is with two chords that intersect inside a circle, you're going to multiply. Product means multiply. Okay, don't forget that. So you're multiplying the measures of the chord segments and they are equal to one another. So notice that these two right here are from the same chord and that these two down here are from the same chord as well. So we don't want to intermingle or do AB and DB. We want to keep it within this exact same chord to keep everything good. So let's just go ahead and do our example then with, okay, what's happening? My pen's freaking out. Oh my gosh. Goodness. Okay, sorry. So looking at this example right here, this is 10. Well, 10 is our radius. So I'm going to go ahead and put that in right there. So if from here, from this center point to here is a radius, well, from this center point to here is also a radius. So this whole thing, and I'm going to go ahead and highlight it to make it stand out a little bit, this thing right here is also going to be 10. But if this little piece right here is 2, that means this yellow piece right here is 10 minus 2, which is 8. Which is really important because what we need to do is take one small segment, which is 2, multiply it by the other segment within the same chord, which is a total of 10 plus 8. So 10 plus 8 is this whole thing here from here to here. So we multiply that by 18. Equals this little chord here, x, times this one over here, x. So we get 36 equals x squared. And remember, to get rid of a square, you do the square root of both sides. So what happens is that your square and your square root are opposites. They undo one another, leaving you with just x. And then the square root of 36 is 6. And that's how you do the chord intersection. The next type of intersection we have is secant-secant. And so for this one, you'll notice that they're coming from the outside. Remember, secant extends, so it's like a chord, only it's longer. It's going to go all the way to the outside. And they have this common meeting point right here at A. So what you're going to do is take your outside, AB, and multiply it by AC, which is the whole thing. And then AD, the outside, times AE, which is the whole thing. So the other words that I like to use and say is exterior times the whole equals exterior times whole. And so it's exterior times the whole thing equals exterior times the whole thing. And sometimes that kind of helps with just the words instead of seeing AB and AC and all these letters. It may not necessarily make any sense. So here's our first example. So we're going to take, these are two secants, right? They extend outside the circle, so now they are a secant. So we're going to take our outside portion of 4, so the outside is 4, and we're going to multiply by the whole thing, which is adding your two pieces together, 4 plus 9. And then set that equal to the outside portion, which is 3, and multiply by the whole thing, which is adding your two pieces together, which is 3 plus x. So here we get 4 times 13 equals 3 times 3 plus x. 4 times 13 is 52. I'm going to distribute the 3 here to get 9, and then distribute the 3 here to get 3x. I'm going to subtract 9 from both sides of the equation to get 43 equals 3x. This becomes a 0. So we then divide by 3. And this does not divide out evenly on the left-hand side, so I'm going to just go ahead and leave it as 43 over 3. Doesn't work out very pretty, so I'm just going to leave that. Now your next type that you have is called a tangent-tangent intersection, and we actually have two different examples for this one. So if you have two tangents that intersect on the outside, so right here, the segments from the intersection, so from the intersection here, so intersection is R, until the point of tangency. So the point of tangency is where does it brush up against the circle? In this case, it would be M and N. There and there, that would be your point of tangency. These are going to be congruent to one another. It's kind of like if you picture a birthday hat on somebody or an ice cream cone, you know, they're the same distance on both sides. So our first example here is you'll notice that this polygon right here is on the outside of the circle, and that's what this word right here means. It means outside the circle. So anytime, So anytime that you, oh my gosh, I'm running out of room on the little thing, sorry, that's an E. But what that means, so anytime you see a polygon circumscribed, it means it's around the circle. So circle's inside that shape. So you'll notice that we have this little point here, and it brushes up against the circle here, 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 and here. So that right there is the point of tangency, where it just barely hits up against it. And so what happens is we have two congruent segments here. But you'll notice that we have this 4 separate times around the entire polygon. So what happens then is that we have those congruent to one another. These are also congruent to one another. And then these ones over here are also congruent to one another. Now you notice that they are not congruent within each individual piece. So from this side to this side, they're not the same. But what we know is that if this is 3.7, this one is 3.7. That's easy. If this is 6.7, then this one over here is 6.7. Well, if this whole thing has to be 12.3, we want to know what's this little piece. So we're going to take our full segment length of 12.3, and we're going to subtract our 6.7 from it. And so what we end up getting there is 5.6, because together they make this 12.3. So if this is 5.6, then this one over here is also 5.6. So the question is, okay, well then how do I get this segment? Well, you take your 13.6 and subtract your 5.6 from it. And when you do that, you end up getting 8. And if that's 8, then this is 8. So our side lengths total, what we have all together, is a 12.3. So we've got 12.3. Plus, and I'm doing this because it's asking for perimeter, plus 13.6, plus this side over here is a total of 11.7, and then this side over here is a total of 10.4. So we add 10.4, and when you add all those together, you get that the perimeter equals 48, when then, you know, whatever units that go with it. Now the second type, you may see it looks like kind of like an ice cream cone problem. So this would be your point of tangency here and here, and that makes these congruent. So all you're going to do is take your 2x plus 8, set it equal to 4x, and then solve. Easy peasy. So these are probably the easiest ones. Divide by 2 on both sides. Those undo one another, leaving you with x equals 4 as your final answer. All right, our final type of intersection that you'll see is a secant-tangent intersection. And so what happens here, you'll see that this AB is your tangent. So AB is the tangent because it just brushes up against the circle. And then AD here is your secant. What you're going to do is you're going to square the tangent. So you do tangent squared. And then you do same as you did before with your secant, where you do your outside times your whole. So square the tangent and then set it equal to exterior times whole. All right, so looking at this example, this 35 just barely brushes up right there. So that's our tangent, making this other one right here, because it goes through twice, that one's our secant. So we are going to square the tangent. So we'll take 35 and we will square it and set it equal to the outside, which is 21, times the length of the whole thing, which means your two pieces added together. 35 squared is 1,225. Over here, I'm going to distribute the 21 to get 441, distribute again to the x to get 21x. Subtract 441 from both sides of your equation. This is a 0. 1,225 minus 441 is 784. And then we divide by 21 on both sides of the equation. So those undo one another, and 784 divided by 12. It does not divide evenly, but the calculator does reduce it to 112 over 3 for you. And I would just leave it like that because it's a repeating decimal. So I know that this is a lot. That's why we're doing this, kind of towards the beginning, so you get a lot more practice with these types because there's a whole lot to it. But the more you do it, the better you will get. So practice, 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 and come in with any questions.